That's true.
Okay. Chapter 9.
Basic girls have weak knees.
It's incredible. Spencer. It's an interesting statement.
I will wait.
Get it.
Okay, so
I forgot that's the first thing.
chapter 9 is going to be the bulk of what you're going to have to do later with Trig.
Okay,
Oh, God.
so basically.
On Thursday.
On a Thursday, I know.
Basically, what I'm saying.
But you can do it.
I'm too old.
So
for
give
this.
me the beat, boy.
I'm teaching
Okay.
old dog new tricks.
No, you got this.
Damn it, I just found
But
this
you did it, so I mean,
I'm about to eat another thing of chapstick.
No,
You eat chapstick?
I did today in Spanish.
He goes, smells good.
no, yes.
And he takes a bite of his chapstick.
8 dogs.
I mean, I did that when I was little with like, do you remember the Mountain Dew and like the
Mountain Dew flavored
my God, the
chapstick.
Dr.
Okay.
Pepper stuff is tasty.
All right, you'll have to talk about that later. Okay, so like the blanket statement I'm going to make about this next couple of sections is going to be you have to think about it not as, oh my God, I don't know how to do that, and like, oh, I'm going to try this thing. Because in this next section, there are a bunch of different ways to solve these problems. And so you have to try something and then figure out if it works.
I feel like Reese's first thought is going to be the total opposite.
It's a lot like when you learned to factor expressions, and sometimes you could factor them using the generic rectangle and the diamond. Sometimes it was the difference of two squares. Sometimes you had to use the quadratic equation. And you had to be a little bit flexible, like, oh, I tried this and it didn't work, so I'm gonna have to try something else. So instead of going like, I don't know what to do and I don't know what to try, it's like, well, I'm gonna try this, and if I hit a dead end, I know I can try something else.
Okay.
Okay. Because this section, you're gonna combine trig and algebra to manipulate equations. What does manipulate mean?
Change.
No.
Nice.
Okay, good job. I promise, even though it's gonna seem complicated at first, it's gonna help you solve complicated equations.
Wait, they get worse?
Yeah, it does. Okay,
Isn't that the lesson with math? Like all these years, you start out with adding and then you get to trig.
we're still adding.
It gets worse,
We're still adding.
but it gets
Okay.
worse.
All right, so you already know, so we call these identities. Identities are like rules, laws, all these ways we can change equations. All right, so you already know one.
Sounds like the Hebrews of the middle school.
So you know the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. That's the Pythagorean identity. So we're going to manipulate this identity to get 2 more. Okay? So I'm going to label this identity number 1 so that I can find it in my notes later. Okay? Then I'm going to label this one identity number 2. And we're going to prove that 1 plus the cotangent squared of theta equals the cosecant squared of theta. Okay, so this is another identity, but we're going to prove it's true. So that's one of the things that you have to do, be able to do with identities, is to like prove that the left-hand side equals the right-hand side. Okay?
Are these what proofs are?
This is what proofs are, where you take two things and you prove that they're the same.
Oh, Zorks.
That's not bad. kind of fun. You got to figure this out. Like, it's like learning a new language.
It's just like
Yeah,
one
like
big
what?
riddle.
It's like learning a new language.
I
Okay.
think
This
your
is
So-
definition of fun is different than mine.
Here's the key. So to do this proof, or really any proof, the key kind of is start with the more complicated side. And then simplify. Because it is way easier, simplify. It is way easier to simplify than to build. Okay, so we start with the complicated side and simplify. So 1 plus the cotangent squared appears to be more complicated. So we're going to start there, and we're going to prove that it equals the cosecant squared. Okay, so I know that the cotangent squared is the cosine over the sine. Right?
Right.
Okay.
Square.
Yes. I'm just bringing the right-hand side along for the ride. It comes along for the ride, and hopefully at some point the left-hand side will say cosecant squared as well. That's our goal, is to get the left-hand side to say cosecant squared and the right-hand side to say cosecant squared. Okay, so using my favorite rule, this is the sine squared over the sine squared. Because 1 can be any fraction I want it to be, as long as the numerator and the denominator are the same. So now I have the sine squared of theta plus the cosine squared of theta over the sine squared of theta. Okay. Well, the reason I chose my 1 to be sine squared over sine squared is because now I can do this addition. Now it's just addition of fractions. So because I have a common denominator, I can add the numerators and put them over the denominator. So I have sine squared of theta plus cosine squared of theta over the sine squared of theta equals the cosecant squared of theta.
Oh, so when it when dividing by sine, that's cosecant too, like that adds to cosecant, because isn't sine plus cosine cosecant, but then you still gotta divide by sine, so therefore wouldn't it just be cosine because of two
Easy.
sines?
Watch what I was doing though. I'm not solving.
Right.
I'm not solving.
Oh,
I'm just proving an equality. So I'm not doing anything with the right-hand side. I'm trying to get the left-hand side to be the same as the right-hand side. So all I did was I did this addition. So I said, okay, because my denominators are the same, I can just add the numerators. So I have sine squared plus cosine squared over the denominator. That's it. And my right-hand side just comes along for the ride.
okay.
Okay. So now, what is the sine squared plus the cosine squared?
1.
1. So now I have 1 over the sine squared of theta equals the cosecant squared of theta. Right? I just simplified the left-hand side. Well, what's 1 over the sine squared? What's 1 over the sine?
Sine to the negative 1.
No.
Sine.
It's the cosecant. Remember those reciprocals?
Yeah.
So 1 over the sine squared is the cosecant squared. My left-hand side equals my right-hand side. So you proved that 1 plus the cotangent squared equals the cosecant squared. Because I started with this, and all I did was use equivalencies to change the left-hand side, and I finally could change it into cosecant squared. So that proves that this is your second identity. Okay? Let's prove your third one. It's very similar.
Oh, my feet are overheating today.
Put them off the table, Alex. You racing a barn?
Yes.
Potentially. Okay, so this is the third trig identity that we're gonna look at. Pythagorean was the first one, the cosecant is the second Pythagorean, and then this is the third one. So 1 plus the tangent squared of theta equals the secant squared of theta. I'm gonna do it almost exactly the same way I did the previous one,
But not quite.
but not quite. So I'm gonna try to get my left-hand side to be secant squared.
Bless you.
Okay, bless you. So 1 plus sine squared over cosine squared. Because sine over cosine is tangent.
Yes. 1 plus sine squared.
What am I probably going to be used for my one identity today? Or right here on this problem.
Cosine.
Yep.
Cosine.
So I'm going to have cosine squared over cosine squared, because that equals 1, plus sine squared over cosine squared, bringing the right-hand side along for the ride. Okay, I have a common denominator, so I can add the numerators. So that's just going to be cosine squared plus sine squared over cosine squared equals the secant squared of theta. The right-hand side comes along for the ride. What is the cosine squared plus the sine squared? 1.
1.
1 over the cosine squared equals the secant squared. What is 1 over cosine? Secant. So secant squared equals the secant squared. Done.
Done.
Okay, so there are 3 Pythagorean identities. Okay? So these are the 3. Sine squared plus cosine equals 1. One plus the cotangent squared equals the cosecant squared. And 1 plus the tangent squared equals the secant squared. Those are the 3 Pythagorean identities. And you can use them in any form. So you could also use 1 minus the cosine squared equals the sine squared. Or 1 minus the sine squared equals the cosine squared. Or the cosecant squared minus the cotangent squared equals 1. Right? Or tangent squared minus secant squared equals -1. You can use them in any form. Those are your Pythagorean identities. Great. What do you remember about even and odd functions?
God, I hate those.
Like almost nothing.
Perfect.
Remember, I didn't like them.
Right. Okay, fair. Because the even and odd function rules give us our next set of identities.
Oh, great.
I know, right? It's okay, I'm going to remind you what they are. So these are the even, odd identities. All right, so let's remember. Here's an odd function. In an odd function, f of negative x equals negative f of x. So f of negative x equals negative y. So if you're thinking of regular, so f of negative x, so all of your x's are over here-ish, equals negative negative y, they're all going to be down here. Of course, you can have a negative, but just remember to think of f of x as y. Okay, and then your even functions, your even function is going to have f of negative x equals f of x. So here you have two negatives. Here you have a negative and a positive. So this is really as much as you need to know about even and odd functions to be able to use these identities.
Okay.
Okay, so don't freak out. So we're going to check the trig functions to see if they're even or odd. Okay, so I'm going to check sine. So sine of negative theta, right, equals negative sine of theta. So we're going to check to see if that's true. If this is true, then the sign is odd. Okay? Well, let's pick
Wait, can't it be neither even nor odd?
the trig functions won't be.
Okay.
They're either even or odd. Okay, well, let's use a theta that we know. Okay? So let's use pi over 4, or 45 degrees. Okay? So the sine of negative pi over 4. Well, negative pi over 4, remember, negatives go clockwise. If you have a negative angle, it's clockwise. So I'm going to go down here to 45 degrees, and the sine is negative square root of 2 over 2.
So yeah, it's odd.
Well,
You're odd.
well, right. How did I write that so it made sense? Okay.
You odd.
Okay, and what about this negative sine of pi over 4? What's the sine of pi over 4? It's the square root of 2 over 2. So negative square root of 2 over 2. So the sine of negative theta equals negative sine of theta. So in fact, the sign is odd. And because the sign is odd, that means exactly this is your first identity. The sine of negative theta equals negative sine of theta. That's your first even odd identity. Okay, so you figure out if the cosine is even or odd. Did you use pi over 4?
Yes. And it's
Yeah.
odd.
It is odd.
What?
No, I'm sorry, it's even.
How do I get odd?
Okay, what's the cosine of negative pi over 4?
2 square root of 2 over 2.
Negative square.
Negative square root of 2.
Really?
No, it's square root of 2 over 2.
Okay, here's negative pi over 4.
Yeah.
Negative square root.
Cosine is square root of 2 over 2.
Yeah.
Yeah, yeah.
So it's positive.
And then the other one's a negative, right?
Wait, where's negative? Oh, I just went off with pi over 4.
Well, but
Because
to
where's negative?
negative pi over 4, you have
Oh,
to
let's go the
start at
opposite
0
way.
and go clockwise
Oh, yeah.
instead of
So
counterclockwise.
it's really
Yeah.
pi or 7 pi over 4.
Yes. Yes.
That's where things got a bit western.
So I need the cosine of negative pi over 4 and the cosine of pi over 4. What's the cosine of pi over 4?
Square root of 2 over 2.
Square root of 2 over 2.
Right.
So the cosine of negative pi over 4 equals the cosine of pi over 4. So the function negative equals the positive, so it is even.
Right.
So cosine is even. So this is our cosine identity. So the cosine of negative theta equals the cosine of theta. So anytime you have cosine of theta in a problem, you can just put cosine of negative theta in there if you want to, and vice versa, if it helps you. Okay. So you could do the same with all of your trig functions. You just check to see if they're even or odd. And when you do that, you get your even odd identities. So here are your even odd identities. So we already know that the sine of negative theta equals negative sine of theta. And we know that the cosine of negative theta equals the cosine of theta. Luckily, they're all odd except for 2. So tangent is odd as well. The tangent of negative theta equals negative tangent of theta. And then the cosecant of negative theta equals negative cosecant of theta. Secant of negative theta equals the secant of theta. So notice how cosine and secant are the only ones that are even. Cotangent of negative theta equals negative cotangent of theta. So those are your even odd identities. The rest of the identities bless you, the rest of this section of identities you already know. Okay, so we have the Pythagorean identities, there are 3 of them. We have 6 even odd. And then the rest of them you already know and we already have been using. But we'll go ahead and name them and list them. So your reciprocal identities . One over the cosecant equals the sine. 1 over the secant equals the cosine. 1 over the cotangent equals the tangent. And then all of the vice versas. So 1 over the sine equals the cosecant. 1 over the cosine equals the secant. And 1 over the tangent equals the cotangent. So those are your reciprocal identities. You can use them whenever you need to. And then your last set, we call them the quotient identities. There are two of them. The tangent of theta equals the sine of theta over the cosine of theta. And the cotangent is the cosine over the sine. Did you like all the rules? Like all the properties, all the characteristics, all the things we can do? And now we're going to do some things.
Can we not do things?
No, we have to do things.
You didn't do things yesterday.
This is the fun part.
I think you're lying.
I like it.
Mine's the same.
That's different.
Wow, Spencer, bring Jesus into this. Why don't
Yeah.
you?
Jesus likes math. It's in the Bible. For real.
Where?
Where?
There's a part about a master mathematician in there. I don't know where, but I can find it.
Caitlin? Where?
I don't know my verses.
I thought you knew literally everything about it, because on Snapchat you send me Bible quotes every day.
Yep.
Yeah.
Every single day I get Bible
Come on,
quotes
Caitlin.
from Caitlin.
There's a joke that I feel like I can say because I'm Catholic, but we're Catholics. We read the bulletin, not the Bible.
Oh.
You know the little like flyer that you read?
Yeah, I get it now.
Okay. Okay, so there are like a couple of different things we can use these for. So we are going to use them to verify
That's a pretty page.
relationships.
Why?
So you might be asked to verify that tangent of theta times cosine of theta equals the sine of theta. Verify is a fancy word for prove. So this is where we're going to take the most complicated side and we're going to make it equal the less complicated side. Okay, so I'm going to start here on this side and I want this side to become sine of theta because then it will match the right hand side. So I'm going to start with a quotient identity. And I'm going to say sine of theta over cosine of theta times cosine of theta hopefully equals the sine of theta. And do you see it?
Yeah.
Clear as mud.
Okay, so this is cosine of theta over 1. It's a multiplication, right?
Oh, yeah.
So I'm just going to multiply.
Can't you just
And I get sine of theta times cosine of theta equals cosine of theta times 1, which is cosine of theta.
cancel those out?
You see it, but I'm going to do it the long way so that you can see. Okay, so now I have sine of theta times cosine over cosine. What's cosine over cosine? 1. So I have the sine of theta times 1. And what is the sine of theta times 1? Sine of theta equals the sine of theta. Done. Okay, so you verify that relationship. You proved that it's true. Sometimes it'll not be true. Sometimes you will not get the left side to equal the right side, and that's when you say this relationship cannot be verified.
Can't be shipped.
Okay?
That was hilarious.
What if you had to verify that 1 plus the sine of x times 1 plus the sine of negative x equals the cosine squared of x?
That was a lot of information.
It was. look for something you can change. You
Me
see, look at your identities.
doing this.
Look at your list of identities and see if there's anything you can.
Alter.
Mm-hmm.
Well.
Can we just like factor that?
You can, but I would do something else first.
Isn't the sign of x the negative sign of x?
Yes, I'm going to use this right here. So I'm going to do 1 plus sine of x. Okay. Remember, the sine of negative x equals the negative sine of x. Okay? So I have 1 minus the sine of x. That was from an even odd identity. So this right here is an even odd. So now you should recognize this as a factored difference of two squares. Okay, if I
Oh, 1 plus and 1 minus.
if I FOIL this out, I get 1 squared plus sine of x minus sine of x, so 0, minus sine squared of x. So I just FOILed this right here. And do you recognize, and so 1 squared is just 1.
Ah,
Just add it
What do you see?
back.
What?
Pythagorean.
It's Pythagorean.
Yeah.
This is the Pythagorean identity. 1 minus sine squared equals cosine squared. Cosine squared equals cosine squared. We're done.
Boom.
Done.
Why do you draw a box?
End of proof. Like the end. Done. The end. All right.
I feel like the box needs a little check mark.
Right? Like, done. You are welcome to put a check mark in there. Okay, so verifying relationships is one of the activities that you have to do with trig identities. You also might have to create a new identity from an existing identity. I'm sure. It's very similar.
I feel like I was warned about these a few times.
It can be rough, but like I said, you just have to go in with that mindset of like, I'm gonna try it. Okay, so for example, you might be asked to write 2 times the tangent of theta secant of theta in terms of sine. So that means we want this same expression, but we want it all to be in sine. We want to get rid of the tangent and the secant and have it all be sine.
well,
So what should we try?
let's turn the tan into sine over cosine.
Let's do that.
Yeah.
2 times the sine of theta over the cosine of theta
Smart.
times the secant of theta over 1, right? Oh, okay.
Over 1.
Great.
Ah,
Now what?
Never say never.
So this was a quotient identity, right? From here to here. How about if we use a reciprocal identity to get rid of the secant?
okay.
Okay.
Okay?
That's like a
So I have 2 times sine over cosine times 1 over the cosine. All right, I'm gonna do the multiplication now.
Okay.
2 times the sine of theta over the cosine squared of theta. So I want everything to be in terms of sine. So how do I get cosine squared to be in terms of sine?
That's another one of those.
But
That's Pythagorean.
What's it?
Alex saw you reading her webs was like, you're gonna get.
so now I'm in terms of sine. So
Oh.
because I started here and all I did was manipulate 2 times the sine of theta over 1 minus the sine squared of theta equals 2 tangent of theta secant of theta.
Oh my gosh.
Right?
This is just like.
Wait, how did
it's
that
just
turn into
like-
tangent?
She just put it
That's what I
right away.
started with.
That's where it
Oh.
started.
So I started here, I did all this stuff and it equals this, but it still equals what I started with because I haven't done anything illegal. Okay,
I'm
so
not a fan
This
of
just
this.
doesn't make sense.
I know.
It's like keeping everything the same with a whole lot of extra steps.
Yeah,
Yes.
it's like, what's the point? The point
Yes.
is what?
because truthfully, it will make an expression way more simple for you to use later on. So using these identities are gonna make expressions usable for you in specific situations. That's why I said it's like not a blanket. It's like it's not, I can't tell you like this is how you always wanna change it. Sometimes you'll want an expression just in terms of sign. Dude,
Sure.
dude, oh.
Aw.
Bro.
Sorry,
Spencer messed
Brisa,
that up.
that was Spencer's fault. Okay, and then the last thing that you might be asked to do is to simplify expressions. Okay? So you might be asked to simplify. Simplifying is always nice. I want you to remember these 2 simplification rules from algebra. Are you ready?
The word simp.
The difference of 2 squares.
Alex. Yeah. Stop.
So difference of 2 squares is when you have a squared minus b squared, and you factor that into a minus b times a plus b, and then you have the perfect square, and that is when a plus b quantity squared equals a squared plus 2ab plus b squared. Or if you have a minus b quantity squared equals a squared minus 2ab plus b squared. So you gotta remember those and be on the lookout for them because they'll show up here. So for example, okay, if we want to simplify this problem, do you see that this looks like 2x squared plus x minus 1?
Yeah, totally.
If
It's exactly what
cosine is just x, right? So I could factor that.
Oh, my hip.
I've heard that.
Just popped
I've heard
very
that.
loudly. Howie.
So if I factored this, I would have 2x plus 1 times x minus 1, right? So I'm just going to replace x with cosine. And then it's just a factoring problem. So 2 cosine plus 1 cosine minus 1 is the simplified version of what we started with. That's it. But now, if I wanted to know where the zeros of this equation was, I could set that equal to 0, solve for theta, and find my 2 zeros. Just like we did when they were algebraic expressions. You look like you totally believe me. What about the cosecant squared of theta minus the cotangent squared of
I'm
theta?
kind of hanging on by a thread.
It's okay.
At this point.
This is one of the topics that, like, we introduce it, then we practice it, then we go back over it, like, it's okay. So we want to simplify that.
Yeah, Breezy, it's a terrible day.
What?
Yeah, Brisa.
It's okay, she'll be fine.
You're gonna.
Well, cosecant squared from a Pythagorean identity is 1 plus the cotangent. So now I have 1 plus the cotangent minus the cotangent.
Wow.
Now that's nicer,
That's kind of easy.
right?
So it's just 1.
It's just 1.
All that for 1.
So we like simplifying.
We like simplifying. So 1 equals the cosecant squared minus the cotangent squared. Right? Because it's the same. We didn't do anything. All we did was manipulate. Okay, you're going to try these. And you're going to love them. Or not.
Big doubt.
The end of 9.1, which is page 704 and 705. You guys don't really have that. And you're going to look at 5 through 33, the odds. It's a lot. It's not really, it's just the odds. It's like 15 problems.
Secant is a hard one to please.
And you get all different varieties. Some are simplify, some are verify, some are
Yeah, actually mine. Yeah.
whatever the other one was.
I am afraid of this.
Create. It's okay to be afraid.
I'll have you on speed dial.
That's fine. You're okay. So the important thing is that you try them and that you come back and you're like, okay, I couldn't get this one. Or I didn't know where to start this one. Or here's what I tried on this one and I never could get what I needed. Okay? Okay. Oh, jeez.
Bye, Brisa.
Bye, Brisa.
Reese's